Today we're going to be talking about mean absolute deviation. I just want to go over some key parts about it. So first, mean. Remember, it's the sum of the values divided by the number of values. Deviation just means different. The point of it is to measure variation. Big equals big. What that means is the greater the greater mean absolute deviation, the greater the variation. And the same works both ways. What we need to do is find the mean, find the differences from the mean, and find the mean of those differences. I took a shortcut and completed step 1 already by finding the mean of both of these data sets. Mean for this set of 4 is 15.25, and the mean of these 4 values is 17.25. Just because one of these has a larger mean does not mean that it has more variation. Does not mean anything yet. All it is that the numbers were just bigger. But variation just says how much space is in between these values. So now let's find the differences from the mean. So I want to compare each value to the mean and tell me how far apart it is. And I'm going to be finding the mean of those values. So the difference between 18 and 15.25 is 2.75. The difference from 12 to 15.25 is 3.25. The distance from 15 and 15.25 is 0.25. And the difference between 16 and 15.25 is 0.75. That's how far they are away from the mean. Now I'm going to be these are the differences between the mean for this first set. For the second set, I'm just trying to compare the variations between the two sets. Between 9 and 17.25 is 8.25. From 25 and 17.25 is 7.75. From 17.25 to 22 is 4.75. And then from 13 to 17.25 is 4.25. Okay. So now what I'm going to do is find the mean. I'm going to be adding all of these values and dividing by the number of values for both of them. Sum of these two is 6. And then the sum of these two is 1. 6 plus 1 equals 7. And I'm going to be dividing by 4 later. For these, I have the sum of these two would be 16. The sum of these two values would be 9. The sum of those would be 25. And now we found the sum of the values, and now we need to divide by the number of values. There are 1, 2, 3, 4 values. I'm going to divide 7 by 4. 4 goes into 7 one time. 4 times 1 is 4. 7 minus 4 is 3. Now I need to bring in a decimal and a 0 so I can bring it down. 4 goes into 30 7 times. 7 times 4 is 28. 30 minus 28 is 2. Bring down another 0. 4 goes into 20. 5 times 4 times 5 is 20. Subtract, you get 0. Oh, just made it. Now I'm going to do the same thing, but with this. Now I have 25 as my sum. I'm going to divide this by 4. 4 goes into 25 6 times. I almost wrote 5. 4 times 6 is 24. 25 minus 24 is 1. Decimals, 0. Bring it down. 4 goes into 10 twice. 4 times 2 is 8. 10 minus 8 is 2. Bring down another 0. 4 goes into 20 5 times. Minus 20 is 0. Okay, now we have Just reestablish the decimal point. Now I have two values. This is my mean absolute deviation. This is also my mean absolute deviation. Now, if I were to be asked, or if I were to ask you, which data set has more variation? You would say this set right here. Why? Because look at the size of this variation. This is 6.25. That is my mean absolute deviation, because since this number is larger than this number, this data set has more variation. So let's walk through everything again. So to solve for mean absolute deviation, I need to find the mean. I take all the values, I find the sum, and I divide by the number of values. This is where my mean comes in. That's step one. I'm going to put a 1 up there. Then, step 2, I need to find the differences from the mean. Okay, how do I do that? I take my mean and I compare it to every single number in my data set. In this case, I only have 4 numbers to compare 18 to 15.25, 12 to 15.25, 15 to 15.25, and 16 to 16.2 to 15.25. These are the values that they are different from the mean by. It takes 2.75 to get from 18 to 15.25. Doesn't matter if I have to add or subtract. It's just telling me how far it is, no matter what. And then I have to find the mean of those values. So how do I solve for mean? Again, I'm going to take the sum of these values, 2.75, 3.25, 0.25, and 0.75. I add it all together and I got 7. These two values together make 6. These two values together make 1. And the sum of those two values makes 7. To finish the mean is, after we find the sum of the values, we have to divide by the number of values. Since when we found the sum of these differences made 7, we divided by 4 because there are 1, 2, 3, 4 numbers. And we got 1.75 as our mean absolute deviation. Very small variation, because look how small that is, 1.75. That's pretty small, because if I compare it to this data set over here, where my mean absolute deviation is 6.25, this side would have more variation because of the larger mean absolute deviation.